All right, everyone. Welcome. The first day of KubeCon is said and done. The European virtual version of KubeCon. Most of the events are recorded, so I'm looking forward to checking out a few of those today. But in the meantime, we have some special guests today to talk about Project Antrea. And Project Antrea, I'll let our experts explain it to you. But joining us is Mr. Ruff back there. Thank you very much for that introduction. We have Antonin Abbas. He's a staff engineer at VMware. Antonin, thank you so much for being here today.
Thanks for having me, Alex. It's great to be here.
Jianjun Shen, senior staff engineer at VMware.
Thanks, Alex. Hello, everyone.
And my co-host, the extraordinary Libby Clark, editorial director and marketing director here at the New Stack. And Libby, I'm going to turn it right over to you. Then I'm going to come back when we're ready for those videos. And I'm excited just to hear what y'all have to say. I may have a question or two, but Libby, take it away.
All right. Thank you, Alex. Well, I'm really excited to hear, first of all, just what Project Antrea is. And I understand that it was recently introduced as a sandbox project to the CNCF. So tell me all about that. Antonin, do you want to start?
Sure. I think I'll let Jianjun introduce the project, and then I can comment on the CNCF donation. Yeah.
No problem. Antrea is an open source cross-network plugin based on OpenVSwitch. Targets for providing networking for any Kubernetes cluster on any platform. The Antrea project was launched in November 2019 during KubeCon North America, actually just 1.5 years ago. And we released Antrea 1.0 version last month. And as Libby said, we're very glad to see Antrea is now a CNCF project. Just last week, Antrea got accepted by CNCF as a sandbox project.
Yeah, those are the two big news items for us. And the last couple of weeks have been very busy with that Antrea 1.0 release, which for us is really like a testimony to how far we've got in the last 18 months. And I think that release marks our desire to show our commitment to the project and our confidence that the project is now like stable enough for production use, for example. Plus, we've introduced some cool new features in that release. And the CNCF donation is the other big news item. That's something that's been on the radar of the Antrea team, the Antrea community for a very long time now. I think the idea first came up about a year ago during an Antrea community meeting, which we have on a bi-weekly basis. And I think our goals with that donation are to increase the visibility of the project, gain more users and contributors potentially that way. And if we can increase synergy with the other CNCF projects, you have that rich ecosystem now that keeps growing and growing. And it can be hard for users to navigate all that. So I think it's important for CNCF projects to maintain that synergy, and that's a great way for users to get like a centralized place where they can look at all that Kubernetes landscape and cloud native landscape. Yeah.
What came up at the time? What was the discussion? To take us back to that time when that discussion first started.
I think Antrea was still like very new at the time, but at the time there were actually no CNI plugin, no Kubernetes network plugin that was a CNCF project as well. Things have changed a little bit since then, but at the time we really wanted to kind of like put Antrea out there, have like a CNCI plugin actually be a CNCF sandbox project. And so that's what kickstarted that decision. And as we like discussed on that, and the kind of like the decision to donate the project started maturing, I think we started to see like all the advantages that a donation like this could bring to the table and bring to the project in terms of long-term progress for the project and long-term viability.
I think from very beginning, we want to go with open governance model, and we definitely want the project to be community-driven. So I think that's also for this reason that we want to delete the CNCF, so we can get more community support and track more users, developers, whatever, as Antonin said.
So you mentioned that it's a Kubernetes network plugin. Can you explain what that means? What are the responsibilities of a network plugin?
Yeah, I can take that. Well, so at the core, it's all about providing connectivity between your Kubernetes pods, right? And so if you look at the Kubernetes documentation, for example, they describe what the network model should be for Kubernetes. And the network model is that there are two requirements. First, pods on a node can communicate with all pods on all other nodes and without address translation. So that's like the first major requirement. And the second one is that all processes on a node, for example, kubelet, can communicate with all pods on that same node. And so a Kubernetes network plugin is in charge of implementing that Kubernetes network model. And the first step in doing that, the first step when you develop a network plugin is to implement an interface called CNI, which stands for Container Network Interface, which is a very simple interface that defines how the container runtime, for example, container D, and the network plugin are going to communicate. So every time a pod is scheduled on a node, kubelet is going to invoke the container runtime, and the container runtime is going to invoke the network plugin through a standard API called CNI. And that's why oftentimes Kubernetes network plugin are referred to as CNI plugins, because implementing that API is kind of like the basic requirements for all those Kubernetes network plugins. But on top of that, all network plugins are going to provide additional functionalities. And for example, implement Kubernetes network policies. Plugins are going to provide their own API with their own capabilities. They're going to provide visibility into the network and so on. Gotcha.
And so where does OpenVSwitch kind of fit into that picture? Because I know that you're built on top, Antrea is built on top of OpenVSwitch.
Yeah, basically we use OpenVSwitch be our data plan. Actually, later, as we see the demo, you can see how we connect pod interface to OpenVSwitch and how OpenVSwitch provide overlay tunnels for the pods cross nodes. And actually, we use OpenVSwitch for all our Antrea Kubernetes networking features, layer 2 to layer 4 features. So it's the balancing and the policy, overlay tunnels. All the features are by OpenVSwitch.
So Antrea is bringing additional functionality on top of that. And some of the things I'm sure we're going to get into at the demos, but can you give me some examples of some of those additional functionalities that Antrea brings?
Yeah, definitely. Of course, as Antonin said, we support all the standard Kubernetes networking features, like the connectivity between pods, connectivity from pods to service, Kubernetes network policies, and we also do service node balancing for Kubernetes service. But besides that, definitely we have many actual features. For example, we invest a lot in network policy front. Besides standard Kubernetes network policies, we have Antrea native network policy, we call it. And we have lots of enterprise security features with Antrea native policies, not in Kubernetes network policies. And also, we try to address troubleshooting the visibility of Kubernetes network. But we do have a few unique features to help diagnose network issues and provide fine-grained visibility into the Kubernetes network. Even for the forwarding front, we do have a few features to provide more flexibility in the pod network. For example, we can allow you to specify which egress IP you want to specify your selected ports to egress the traffic from the cluster to the external network. And we're adding more and more features actually. Later we'll probably talk more as we see the demo.
And I just wanted to add that OpenVSwitch is often referred to as a programmable virtual switch. So This means that you basically configure your data path to process packets the way you want it to process packets. And that programmability lets us implement all the Kubernetes features, networking features, like Jianjun say, in kind of like with one technology and in one place that is easy to look at and easy to understand or troubleshoot. So everything from basic L2, L3 connectivity to layer 4 service load balancing to network policy implementation in a stateful firewall way, right? Because OpenVSwitch can interact with connection tracking. So everything can be done in OpenVSwitch. So we have that unified data path, which is also portable.
Does that go ahead?
I was going to say you can see the flow too in real time, which I think is really cool. So I just want to get into the demos because I think it's really cool to see.
Yeah, let's go to those demos.
Yeah, why not do it? Yeah. Oh, let's start from the beginning. So this demo is about how Antrea implements cross networking on Linux and Windows with OpenVSwitch uniformly. As we talked, actually on both Linux and Windows, Antrea use OpenVSwitch to be the data plan for all the networking features. So here we have a Kubernetes cluster with 3 Linux nodes and 1 Windows node, including 1 ARM node. You can see Antrea is already running on the cluster. We have 4 Antrea agent ports running on the 4 nodes. And we also have a single Antrea controller port running. So on both Linux and Windows, Antrea use OpenVSwitch to be the network data plan. And on the Linux node, we actually run OS daemons inside the Antrea agent port. So if we log into one of the agent port here, we can run an OS command to dump the OS config. You can see we have an OS bridge called brint created on the node, and every local port has a network interface connected to the bridge. The same on Windows, we can run the same OS command to dump the OS config. And you can see the same OS bridge created on the node, and the water port has a network interface connected to the bridge. Almost all Antrea features are implemented the same way with OpenVSwitch on Linux and Windows. And we have the same troubleshooting tools available on both. For example, you can use our command line tool called undercutter to troubleshoot and to dump the state on the node. You can also dump the OS flow entries for a specific feature. For example, you can see the service load balancing flows. The same thing on Windows. The same undercutter commands can be used to dump the Antrea state and to dump the OS flows. And you can see even for the OS flows implementing the same feature, like service load balancing is exactly the same between Linux and Windows. Next, we look at the unique feature in Antrea called trace flow, which allows you to trace the packet in the port network and report the end-to-end forwarding paths. So we can start trace flow from Antrea alternate UI. Here, you can specify the source port of the trace flow packet, and we use Kubernetes service to be the destination in this example. And once you start the trace flow, Antrea will inject the packet on the source port into the OS bridge. And then it will trace the packet forwarding paths in the port network. Antrea alternate UI can visualize the trace flow result with a graph. So, for example, here you can see the packet is sent from the source port on the Linux node, and it passes Antrea's guard and passes service load balancing with one of the backend server to be selected as the destination. And in our case, the server port actually is the Windows port. So the packet tunneled from Linux node to the Windows node. But it doesn't pass the ingress net policy enforced on the server port. So you can see it's finally dropped by Antrea native class network policy called cross-tenant delay. Yeah, so it provides a very intuitive way to troubleshoot your port network and how packets is forwarded in the port network. Yeah, I think that's a demo.
So can you so basically what I'm seeing is you're able to troubleshoot across nodes even if they're running different operating systems, if you're Windows or Linux. And you're also able to control them from one place, right? And
Yes.
see the network traffic from one single place. Can you explain why that's so important? And who's your ideal user?
Sure. I think the user can be the cluster admin and can also be the developer. I think it's important just because in Kubernetes world, it's pretty hard to troubleshoot networking because you have so many containers. You can have so many containers in the cluster, they can't go. It's very volatile compared to VMware clouds, right? And then I think the traditional way to troubleshoot doesn't work for you. For example, it's very hard for developer to understand the low-level networking. It's hard for them to correlate the IP address to their workloads. So it's hard for them to troubleshoot with IP address, for example. But with Antrea, since we do this correlation from high-level construct to low-level state, for example, with TraceFlow, you can use high-level construct to define a TraceFlow packet between ports or between port service. Then from our Octane UI, or you can also use our command line tool, or even you can use KubeCon. You can start a TraceFlow between these high-level constructs, and you can see the end-to-end forwarding paths, including how they are passing different stage in the forwarding pipeline. So I would say it's very intuitive way of to understand the network and see how package is forwarded by Antrea in the network.
Yeah, and developers have direct access to that and command line access.
Yep.
Wow. Great.
Yeah, good to know.
Yeah, it's all about building those layers of abstraction and then being able to walk through that as a DevOps engineer or as a cluster administrator to try to figure out what's going on. So you can start at the top and then like dig deeper based on what the issue is and what your level of expertise in networking is.
Yeah.
What about the network policy implementation that you talked about earlier? Is that part of this as well?
Yeah. Sure. First, for TraceFlow, I think you already see we can also trace how the packet pass net policies. And in our examples we just showed, the packet actually dropped by a net policy, and we can from result we can see exactly which net policy dropped or passed the packet. And definitely, we also have other troubleshooting features can also let you know how the packet is enforced, what net policy are enforced for your traffic, and whether that policy is really realized by OpenVSwitch or not. And you can even map the net policy to the low-end flows if you want to do some deep troubleshooting to just make sure it's really realized correctly. Antonin, please go ahead. Sorry.
Yeah, I was just going to give some context about Kubernetes network policies for viewers if you think it's a good idea. Yeah.
Yes.
Yeah. So, well, what are Kubernetes network policies? Kubernetes network policies is a standard API provided by Kubernetes that network plugins are free to implement. And most popular plugins actually do implement that API, right? If you look at Antrea, if you look at Calico, if you look at Cilium, but some plugins do not implement Kubernetes network policy API. For example, if you know about Flannel, or in cloud managed services such as like EKS or GKE, typically network plugins are not supported out of the box by the CNI plugin, which is native to the VPC. So network policies are a concept to secure Kubernetes applications at layer 3, layer 4. So by default, all Kubernetes pods are able to communicate with each other. And we go back to that Kubernetes networking model I was talking about before, which is that all pods can communicate with all other pods across all nodes without address translation. Well, that's going to change as soon as you define a Kubernetes network policy and you apply it to a specific set of pods. When you do that, that set of pods is going to become isolated, which is a term that they use in the Kubernetes documentation, in the Kubernetes ecosystem, to say that that pod is not going to be able to initiate or receive connections anymore unless you explicitly authorize it to connect to a specific pod or to receive connections from a specific pod. And so why would you want to define network policies? Typically, it's going to be to secure sensitive data or sensitive applications, and that could even be for compliance reasons, right, in the domain of the enterprise. And in a multi-tenant cluster, and that was kind of like, if you were paying attention when Jianjun was showing the traceroute example, you saw that the policy dropping the traffic was called multi-tenant deny traffic or something like this. So the idea is that if you have multiple tenants sharing a cluster and each tenant has its own namespace, you can prevent cross namespace traffic unless it is necessary for your applications, and kind of like isolate tenants this way.
Great. Let's get into the second video. And I know you're going to be talking. I just want to give it a quick review because we have 2 more videos to do, this one and the next one. So this one's going to be about Antrea network policies to secure the pod network. And then the next one will be about flow visualization with Antrea and the Elk stack. I want to make sure that people realize that they can ask questions here. Please ask your questions, add them to the YouTube comments. Libby, take it away.
Yeah, I want to see this, the network policy in action.
All right, so the video is going to show the next level up, right? Because it's not just going to be Kubernetes network policies. It's also going to use Antrea native policies, which are extension APIs provided by Antrea to kind of like complement what Kubernetes network policies can do.
Perfect.
So here we have a couple of pods in the tenant A namespace. So going back to that multi-tenant use case I was describing, and we have a services as well for tenant B, and we also for tenant A, sorry, and we also have some pods in the tenant B namespace. And by default, as I said, all pods can communicate across all namespaces, which means that a pod in the tenant B namespace can access a service provided by tenant A. You can see that here we're just doing a curl from tenant B to tenant A, and it's just working. And that's probably not what we want to have here. So in Antrea, we have a rich network policy model. As I said, we build upon the Kubernetes network policy API. And in particular, we support like multiple tiers, which tiers are a way to organize your policies by priority level and by persona in a way, and yeah, be able to organize the policies in the ways that make sense for your use case. So here for that video, we're going to define a set of policies to kind of like secure our cluster. So by default, in a high policy tier that you see on the left, which we call security ops in that case, but once again, you can configure your Antrea policy tiers in any way you want. We're going to prevent cross-tenant traffic. Then we're going to have like a policy to authorize all DNS traffic. Otherwise, your pods are not going to be able to access the DNS service, and are probably not going to be able to do anything useful. And then we're going to authorize client-server traffic within a namespace, in that case, a tenant A namespace. So I'm just going to like show some of those policies here, and then we're going to apply them to the cluster. So this is my high priority policy, which is going to prevent traffic across different tenants, across different namespaces. And I've highlighted a few things in that video which are interesting. So you can see we're on the security ops tier, which again is a high priority tier, which would typically be not managed by a developer or a DevOps team, but would be managed by your cluster administrator, your cluster provider, or some infrastructure team potentially. We're going to use the reject action, which is a concept specific to Antrea. That's not something that's part of the standard Kubernetes network policy API. And what reject action means is that if some traffic is found to violate a network policy, instead of silently dropping the packet, you're going to send back a TCP reset or an ICMP message to let the client know right away that this is not an allowed connection. And the last thing we have here is we enable logging for the policy, which means that we're going to log information about all the connections that we reject, which again is a very useful feature provided by Antrea if you want to kind of like audit the traffic going through your cluster.
So we have a question coming in from Susan Wu from VMware, who's wondering, are network policy rules like a firewall?
They're very much like a firewall. You can think of network policies like a stateful network firewall, but you're going to be securing the pod network of a Kubernetes cluster as opposed to securing infrastructure, for example. And Kubernetes network policies are going to be application-centric in that you select a group of pods using Kubernetes labels and you apply policies to them. So you don't have to reason in terms of IP addresses, which in the context of Kubernetes and pods are going to be ephemeral, right? So instead, you reason in terms of the application, in terms of Kubernetes labels. But you can very much think of network policies as a stateful network firewall. I hope that answers the questions.
We also got a shout out from Project Antrea. Hi, everyone.
There was another question too, I believe, from JVS, and he asks, is the policy API entirely implemented in OVS?
Yes, I see. The short answer, yes. Actually, I use OpenVSwitch for most of our features, and definitely for lab policy is totally by OpenVSwitch.
And yeah, and going back to that stateful firewall aspect, yeah, OpenVSwitch is going to interact with contract, the connection tracking module, and get information about connections necessary to enforce network policies. Yeah. So thanks for the questions, everyone. So I'll just keep playing the video here. We are just like defining the additional policies that I showed in my diagram before to kind of like get our complete network policy model, and we're going to apply all of them. And now that we've applied those policies, we can check if they've been enforced, if they're being enforced correctly. So kind of going to run a few tests here. We're going to see if tenant B is still able to access the services from tenant A, and we can see that it's no longer the case here. My curl command is going to fail, and because we use the reject action, we're notified right away instead of like having the curl command hang and timeout basically. So we're accessing our Windows web server. Sorry, we cannot access the Windows web server. We cannot access the Linux Nginx web server. But if we look at tenant A, of course, tenant A is able to access the service if we look at the correct client, and if we look at the non-correct client, tenant A is not able to access the service anymore. And yeah, and we saw the distinction here between the drop action and the reject action, where the reject action is going to reject traffic right away, but the drop action is going to drop traffic silently and lead to a timeout on the client side. And this is just like, yeah, going back to TraceFlow again, now that you have more context about network policies. I mean, Jianjun talked about this already, but basically you can validate your network policy implementation using TraceFlow, and you can also troubleshoot connectivity issues using TraceFlow by figuring out why packets are dropped, for example. And yeah, we talked about logging as being a feature added by Antrea to support auditing connections in your cluster. So you can see on each node, we're going to keep a log of rejected connection or allowed connection for network policies for which you've enabled logging. And once again, that's something that's available on both Linux and Windows. So you can collect those logs in a centralized location and figure out which connections are trying to violate existing network policies.
So you mentioned the integration with OpenVSwitch OVS. Does Antrea integrate with other security projects, and how does that work?
I can take this one. You want me to take this one, Jianjun?
Yeah, you can start first. I can add mine.
Okay. So in terms of integrating with other security solutions, this is still something we're looking into. I think we'd like to have Antrea integrate with systems like IDS or IPS systems, like something like Suricata. So with OpenVSwitch, with Antrea, we can steer pod traffic towards a system doing IDS or IPS, for example, and be able to monitor traffic this way at a layer which is not supported directly by Antrea, right? So Antrea is going to mostly operate at layer 3 or layer 4. So if you want to dig deeper into the packet and apply security rules at layer 7, for example, you have to integrate with other software components, because Antrea is not going to have that functionality out of the box just with OpenVSwitch. So we can integrate with things like Envoy, have an Envoy proxy, for example, if we want to implement layer 7 security policies in Antrea. So let you define roles based on HTTP resources or gRPC calls, for example. And we can also integrate with IDS IPS systems by steering the appropriate traffic to the appropriate software for inspection.
So we have another question from Jay, who's asking, can we use the same stuff to troubleshoot where service proxy packets are being dropped?
I think if you mean trace flow, definitely it can cover the service load balancing. And I think we already saw in our example, that particular packet we issued definitely pass the service load balancing with one of the Windows port to be selected to be the backend port, right? But I don't think service load balancing will drop the packet. So if that's a question, we do cover a service load balancing, but it's typically doesn't drop the packet. I just want to add a few comments about the last question for security solutions. I think definitely, as Antonin said, we want to build an open system that can integrate with other security solutions. I think Antonin talked about we can capture packets and streaming them to service like IDS, IPS, and maybe also network detection and response. And since we have this policy tiering model, we believe we can enable any policy manager to push global policies or the main policies to Kubernetes clusters. And later, I think if we have time, we have a demo about how Antrea can export network flows with Kubernetes context to any network flow consumer. So you can consume the flow to build traffic monitoring, threat detection, policy recommendation, many features with this network flows from Antrea. So really, we believe with Antrea, you can build many security services with the information we export, with the packet we can capture.
Great. So I understand you just said you have a final kind of video to show us that shows those network flows. Personally, this was the one I found most exciting because I love visualization. So can you show us exactly how that works?
Yeah, I'll show the video. And just to give some context, so this is showing a feature that we call Flow Exporter that Jianjun just briefly referred to. So Antrea runs an agent on every Kubernetes node, and this agent is going to monitor the connection tracking table and send information about the flows going through each node to a central location that we call the flow aggregator. And then that flow aggregator can forward the information to a central collector. And in that case, we use like a reference collector, which is based on the ELK stack. So Elastic, Logstash, Kibana. And Kibana is going to provide a UI with dashboards so you can kind of like monitor all the traffic that's going through your cluster. And we use a technology called IPFix to export flow information from the cluster to the collector. So here I'm just showing that we're running like kind of like an ELK stack as part of the cluster. So we have a Logstash, Elastic, Kibana deployment. And the Antrea agents are going to be sending flow information using IPFix. So if we look at the first kind of like dashboard in the Kibana UI, we can see that there is a way to display all the IPFix records received from Antrea, from the Antrea flow aggregator. And we're going to see what's very interesting is that kind of like by default in the standard way, oh, sorry, I click on the wrong thing. by default, in a standard way, in the standard IP fix, right, the information you get is kind of like really network centric. So you're going to get things like the source IP address for the flow, the destination IP address for the flow. So you're going to get some packet counts, byte counts, for example. But what Antrea is going to do is it's going to complement that information with Kubernetes-specific information. So, for example, namespace of the source pod, namespace of the destination pod, namespace of the destination service, and name of the destination service if you're sending traffic to a service. So we're going back to what Jianjun talked about when we're talking about troubleshooting, right? It's all about taking those tools and adding some Kubernetes context to it so that a user can quickly figure out what's going on in the cluster. And here in the video, you can see that we added a destination node name, destination pod name, and all that information, which is going to help you understand which flow you're looking at right now. So we do add a lot of that context, and I'm just kind of like showing. We also have information about network policies. So if a connection is allowed by a specific network policy, which network policy is allowing it, and so you basically have that ability from that information as a cluster administrator to figuratively like zoom out and look at bandwidth distribution in the cluster, figure out which nodes are communicating, which namespaces are communicating using that information. And we're going to look at a different graph kind of like showing that bandwidth distribution, that bandwidth evolution. And you can also zoom in, right, and figure out which network policy is authorizing a specific flow that you're looking at, for example. So yeah, you basically, using those UI Kibana dashboards, you have the ability to troubleshoot at different levels or figure out what's going on at different levels, and you're able to monitor what's going on in the cluster.
So you can figure out if you need to change your network policies, or if just basically insight into how your application is performing, right?
So if you observe high latency, for example, that may be because there is like too much traffic between some services, right? And so you're able to look at that bandwidth distribution, figure out if someone is hogging all the bandwidth in your cluster. And going back to the beginning of your question, if you see a connection that looks suspicious, maybe you're able to figure out which network policy is permitting that connection, even though based on what you've defined, based on your configuration, you would expect that connection not to be possible, right? And here we're just looking at the UI, but using that same information, as Jianjun said, you can really like integrate with more advanced security systems or recommendation systems.
So let me ask a question then. So let's say we have an organization that's now going to invest deeply in Kubernetes. They've decided they are going to make that jump from test into more full-scale production of Kubernetes. But they have an issue because they have multiple teams who want to use Kubernetes. They want to be able to leverage it. And so there's a decision made to run all the teams on one cluster. And so now everyone has access to the cluster. How do you start visualizing that so you can actually start to be able to manage it more effectively and manage the, all these different matters that come up when you have a multi-tenant environment?
You want me to go? I can go. So yeah, I mean, it's so you're referring to a specific Kubernetes deployment, right? Where you would have like typically that multi-tenant situation we described, where you would give out different namespaces to different teams, right? So I think the first step is using network policies. You would be able to like secure things, and if like application for two different teams are not supposed to interact, that's something you would be able to block, to deny. And using that flow visualization tools or all the tools you can build using that IPFix information export, you're really able to monitor what's going on in the cluster, see what kind of like cross namespace, cross tenant communication is happening, figure out if there is a lot of bandwidth moving between those two tenants and two namespaces, two teams, and you're really able to keep track of everything that's going on in the cluster at the network level.
I have to say, in this multi-tenancy environment, our policy tiering model really helps, because now it allows you to create multiple tiers of policy. For example, you can have security admin that want to apply some global policy at the highest tier that can be enforced in precedence to other tiers. But you can also assign some tiers to your tenant admin for each tenant, so they can define their own policies in their tiers. And finally, you can have developers just belong to one tenant. They just create their resource in one namespace, for example. And they can create cross-tenant policies in that namespace. And the OS policy, they can work together. For example, developer cannot overlap your tenant admin policies, and tenant admin cannot override the security team created policies.
And that, as Jianjun said, the fact that you cannot override is very important, right? So if you have like a data compliance team, maybe a data compliance engineer, he can really define like policies in a high priority tier, which are not going to be, which cannot be overridden by any policy defined by a DevOps team. So if you have a very sensitive data in the cluster and you have a compliance rule that says that your cluster should not be able to access the internet or a specific CIDR block in the internet, you can have your data compliance engineer define that policy in a high priority tier, and DevOps teams cannot change that policy in any way.
Great. Well, this was really interesting deep dive into Antrea. I really appreciate having you both here, Antonin and Jianjun. I would love to hear, just if you're interested in learning more about the project or contributing to the project, where should you go?
That's the easiest question so far. So, if you've never used Antrea and you're a Kubernetes user, it's very easy to give Antrea a try by deploying it in a cluster. So all the resources needed by Antrea are defined in a single YAML manifest, so you can just apply it directly with one kubectl command line invocation, and path Antrea is going to be running in your cluster. And if you do give Antrea a try, we really value any feedback or suggestions you may have, so you can reach out to us on GitHub, on the Antrea channel on the Kubernetes Slack. And we have bi-weekly office hours, which are very accessible as well. So you can just drop in, and there is always like a couple of us Antrea maintainers like staffing those office hours. So we're very happy to have a chat. It's very informal. So just drop by with any question you may have.
Yeah, and also give us feedback. We do have a roadmap, and we have many new features in the roadmap, and there are many ideas we want to do towards 2.0. But definitely, we like to see all your suggestions, any requirement you have. Just let us know through Slack channels, GitHub issues, and we will be very happy to address your requirements.
No, I think Alex is muted.
Of course. Well, thank you so much for joining us and in this discussion. And thanks to Mr. Ruff, who did show up on occasion for a little point of view of their own. But the questions were good. I appreciate it. The videos were excellent. Thank you, Antonin and Jianjun. We will look forward to hearing more about Project Antrea as it develops.
Thanks, Libby. Thanks, Alex.
Thank you. Yes. Bye-bye.